Hello and welcome to OKellyChemistry.com. I'm Ivana O'Kelly and thanks for joining me. In this video, I'm going to talk you through 4 different types of stoichiometric calculations. We're going to look at a grams to grams calculation. We're then going to determine the limiting reactant. We're then going to look at excess reactant and determine how much is left over. And finally, I'll walk you through a theoretical yield calculation. So grab your pen and paper and let's get started. So obviously there are some steps involved. So the first is we're going to start with a balanced equation. Next, from our question, we're going to identify our given. That's going to be a number with unit. Then we'll identify our unknown, which will just be a unit. So we're going to see how much. And then we'll map out our problem, followed by performing the calculations in our calculator and our final check for sig figs, which is determined by the number that's given in the question. So here's a sample question, and it reads, how many grams of oxygen are needed to react with 56.8 grams of ammonia by the reaction above? So we have 4 moles of ammonia will react with 5 moles of oxygen, yielding us 4 moles of nitrogen monoxide and 6 moles of water. So our given will be our 56.8 grams of ammonia, and our unknown will be our grams of oxygen. Now we can see that oxygen is a diatomic, so we'll keep that in mind when we're calculating our molar mass. So now we need to map out the problem. So we see here that we have our given, and we also want to determine how are we going to get to our unknown. So we take our 56 grams of our ammonia. We have to go from grams to moles, so we'll divide by the molar mass of our NH3. And then from our balanced equation, we're going to figure out our mole ratio. So that will be our coefficients. So we see oxygen is 5 and ammonia is 4. And then that will give us our moles of oxygen, and then we'll multiply by our molar mass of O2 to give us our grams of oxygen. So performing the calculation, what will go into your calculator is your 56.8 grams of your ammonia. Divide that by 17.03 grams of NH3. Our mole ratio is 5/4. And then we'll multiply by 32.00 grams of O2. So you can pause the video and run these numbers through your calculator. And we'll make sure that our final answer has 3 significant figures in it. So that will be 133 grams of oxygen. So the next type of calculation is how do we determine our limiting reactant? Sometimes this is referred to as the limiting reagent. So our limiting reactant is the substance that's going to run out first in your chemical reaction. And as a result, it's going to determine how much of the product that you're actually going to make. So in order to do these types of calculations, we're going to have to compare each reactant with the product. And the one that makes the least amount of product, that's going to be determined, and that will be our limiting reactant. So here I have a sample question for us. So if 15 grams of zinc 2 chloride reacts with 20.0 grams of lithium nitrate, how much lithium chloride can be formed? So obviously we need to start with a balanced equation. And I find that if I color code each substance that's mentioned in the question, it helps me set up these calculations a little easier, and hopefully it'll help you too. So ultimately, we're going to be comparing our blue with our yellow, and we're going to be comparing our green with our yellow. So we'll compare our grams of zinc 2 chloride, seeing how much grams of lithium chloride we'll make. And then we're going to compare our grams of our lithium nitrate to determine how many grams of lithium chloride. So we set up our calculation, 15.0 grams of zinc 2 chloride, divide that by its molar mass. And then from your equation, you're able to determine what is your mole ratio. And our final answer will be multiplied by 42.39 grams of lithium chloride. Then we'll take our grams of our lithium nitrate. We'll divide it by its molar mass, which is 69.05 grams. Our mole ratio in this situation is 2/2, and we're multiplying by our 42.39 grams of lithium chloride. So if you run those numbers through your calculator, the first one is going to give us 9.33 grams of lithium chloride, and our lithium nitrate is going to yield us 14.1 grams of lithium chloride. So we can see that the zinc chloride produced only 9.3 grams of lithium chloride. So therefore, our zinc chloride is going to be our limiting reactant, and the amount of lithium chloride that we make will be 9.33 grams. So for this style of a question, where we're finding the amount of excess reactant that is left over, we have a couple more steps that we need to do. We're still going to start with a balanced equation, and then we're going to determine our limiting reactant, so which of our two reactants is going to make the least amount of product. From that, we're going to have to determine the amount of excess that's used up. So we'll take our grams of our limiting reactant to our grams of our excess reactant, and then we're going to determine how much excess reactant is left over. We'll take our initial amount of our excess reactant, and again that's given to us in the question, and we will subtract the amount of excess reactant that was used up. So here we have a sample question. How many grams of aluminum chloride could be produced from 24.0 grams of aluminum and 29.0 grams of chlorine? And then we're going to determine how much excess reactant is left over. So here's our balanced equation. We have 3 moles of aluminum reacting with 2 moles of chlorine, yielding us 3 moles of aluminum chloride. So we're going to compare each of our reactants with our product. So we'll take our grams of our aluminum, we'll divide it by its molar mass, we'll apply our mole ratio taken from our balanced equation, and then we'll multiply by our molar mass of aluminum chloride. And that gives us 119 grams of aluminum chloride. For our other reactant, chlorine, we'll go ahead and we'll divide by its molar mass, we'll apply our mole ratio, and we'll multiply by our molar mass of our aluminum chloride. And that gives us 81.8 grams of aluminum chloride. So from this, we can see that our chlorine is our limiting reactant. So it's a good idea to go ahead and label that in your reaction. So the chlorine is the limiting reactant and your aluminum is your excess reactant. So now what we need to do is we're going to take our grams of our limiting and we're going to compare that to our grams of our excess. So we'll take our 29.0 grams of chlorine, we'll divide by its molar mass, we'll apply our mole ratio, our unknown over our known, and then we'll multiply by our molar mass of aluminum. So that gives us 16.6 grams of aluminum. So now for the last part, we're going to take the initial excess reactant from our question, which was 24.0, and we're going to subtract our 16.6, and we see that our final answer is 3.4 grams of aluminum. Now notice for sig figs, because it's a subtraction, we're going by the least number of decimal places. And finally, this question, what is the theoretical yield of iron 2 fluoride if I start with 33.0 grams of iron 2 chloride? What is my percent yield of iron 2 fluoride if the actual yield is 21.0 grams? So very simply, we're going to take our start of the balanced equation, we'll determine our theoretical yield, and then we will determine our percentage yield, which will be our actual divided by our theoretical multiplied by 100. So we're taking our grams of our iron 2 chloride to our grams of our iron 2 fluoride. We'll set up our calculation, grams of FeCl2, divide by its molar mass, multiply by our mole ratio, which is 1/1, and then we'll multiply by our grams of our iron 2 fluoride. So that's going to give us 23.9 grams of iron 2 fluoride. So to get our percentage yield, our actual was 21.0 grams, so that was given to us in the question. And we're dividing it by our theoretical, which we calculated to be 23.9 grams of FeF2. Multiply that by 100, and we see that our percentage yield is 87.9%. So ladies and gents, I hope that was helpful to you as you were able to see the different types of stoichiometric calculations. I would encourage you to go ahead and watch back over the video and pause it. Obviously, using colors is helpful for some students. So hopefully this was good for you. If you do like this video, go ahead and like and subscribe, and I'll see you very soon.